Classification of planets. Planets are classified based on a variety of factors, including their size, composition, and distance from their host star. The classification of planets has evolved over time as new discoveries have been made and our understanding of planetary systems has deepened. Terrestrial planets. Terrestrial planets, also known as rocky planets, are planets that are similar in composition to Earth. They are typically small and dense, with a solid surface and a thin atmosphere. The 4 terrestrial planets in our solar system are Mercury, Venus, Earth, and Mars. Terrestrial planets are believed to form close to their host star, where the temperatures are high enough to melt and differentiate the rock and metal in the protoplanetary disk. They are also more likely to have magnetic fields and plate tectonics, which are important for maintaining a stable climate and habitable environment. Gas giant planets. Gas giant planets are planets that are primarily composed of hydrogen and helium, with a small rocky core. They are typically much larger than terrestrial planets and have thick atmospheres with no solid surface. The 4 gas giant planets in our solar system are Jupiter, Saturn, Uranus, and Neptune. Gas giant planets are believed to form farther from their host star, where the temperatures are cooler and the density of gas and dust in the protoplanetary disk is higher. They are also more likely to have a system of rings and numerous moons. Ice giant planets. Ice giant planets are planets that are similar in composition to gas giant planets but have a much higher proportion of ices, such as water, methane, and ammonia. The 2 ice giant planets in our solar system are Uranus and Neptune. Ice giant planets are believed to form farther from their host star than gas giant planets. Where the temperatures are low enough for ices to condense and form solid particles in the protoplanetary disk. Dwarf planets. Dwarf planets are objects that are similar in size and composition to planets but have not cleared their orbit of debris. There are currently 5 recognized dwarf planets in our solar system: Ceres, Pluto, Haumea, Makemake, and Eris. Dwarf planets are believed to form in a similar way to planets but were not able to clear their orbit due to the gravitational influence of larger objects in their vicinity. Exoplanets. Exoplanets are planets that orbit stars other than the Sun. They can be classified using the same criteria as planets in our solar system, including size, composition, and distance from their host star. The study of exoplanets has revealed a diverse array of planetary systems, including planets that are much larger than Jupiter. Planets that orbit multiple stars, and planets that orbit in the habitable zone of their host star. Future directions. The study of planetary classification is a rapidly evolving field, with new discoveries and innovations constantly emerging. In the coming years, advances in observational techniques and theoretical modeling will continue to deepen our understanding of planetary systems and the diversity of planets and their properties. Hot Jupiters. Hot Jupiters are a type of exoplanet that are gas giant planets similar in size to Jupiter, but orbit very close to their host star. They typically have short orbital periods and high temperatures, which can be thousands of degrees Celsius. Hot Jupiters are believed to form farther from their host star and migrate inward due to gravitational interactions with other planets or the protoplanetary disk. The study of hot Jupiters provides insights into the formation and migration of planetary systems, as well as the extreme conditions that can exist in the universe. Super-Earths. Super-Earths are a type of exoplanet that are larger than Earth but smaller than gas giant planets. They are typically composed of rock and metal, with a solid surface and a thin atmosphere. Super-Earths are believed to form close to their host star, where the temperatures are high enough to melt and differentiate the rock and metal in the protoplanetary disk. The study of super-Earths provides insights into the diversity of planetary systems and the potential for habitable environments beyond our own solar system. Mini-Neptunes. Mini-Neptunes are a type of exoplanet that are similar in size to super-Earths but have a much thicker atmosphere, typically composed of hydrogen, helium, and other volatile compounds. Mini-Neptunes are believed to form farther from their host star than super-Earths, where the temperatures are cooler and the density of gas and dust in the protoplanetary disk is higher. The study of mini-Neptunes provides insights into the diversity of planetary systems and the conditions necessary for the formation and evolution of different types of planets. Rogue planets. Rogue planets, also known as free-floating planets, are planets that are not gravitationally bound to any star. They are typically formed in protoplanetary disks like other planets but are ejected from their system due to gravitational interactions with other planets or the protoplanetary disk. The study of rogue planets provides insights into the conditions necessary for the formation and evolution of planets, as well as the potential for habitable environments beyond our own solar system. Future directions. The study of planetary classification is a rapidly evolving field, with new discoveries and innovations constantly emerging. In the coming years, advances in observational techniques and theoretical modeling will continue to deepen our understanding of planetary systems and the diversity of planets and their properties. In addition, new missions and future observatories, such as the James Webb Space Telescope and the European Space Agency's Ariel mission, will provide unprecedented views of exoplanets and their atmospheres, allowing for more detailed classification and characterization of these planets. Chthonian planets. Chthonian planets are a type of exoplanet that are similar in size to gas giants, but have lost most of their gas due to their close proximity to their host star. As a result, they have a high density and are composed mostly of rock and metal. Chthonian planets are believed to form farther from their host star and migrate inward due to gravitational interactions with other planets or the protoplanetary disk. The study of Chthonian planets provides insights into the formation and migration of planetary systems, as well as the extreme conditions that can exist in the universe. Positioning of celestial bodies in space. Astronomy is the study of celestial objects in space, and the accurate positioning and tracking of these objects is a crucial aspect of modern astronomy. The position of a celestial object can be determined using a variety of techniques, including astrometry, celestial mechanics, and satellite-based observations. Astrometry. Astrometry is the precise measurement of the positions and motions of celestial objects. This is typically done using telescopes and specialized instruments, such as the astrolabe or the meridian circle. These instruments allow astronomers to measure the positions of stars and other objects relative to a fixed reference point, such as the celestial equator or the ecliptic. Astrometry is important for accurately tracking the positions and motions of objects in the solar system, including planets, asteroids, and comets. It is also used to study the positions and distances of stars in the galaxy, and to measure the movement of galaxies and other objects in the universe. Celestial mechanics. Celestial mechanics is the study of the motion of celestial objects under the influence of gravitational forces. This is typically done using mathematical models, such as Newton's laws of motion and the laws of gravitation, to calculate the positions and trajectories of objects in space. Celestial mechanics is important for accurately predicting the positions and motions of objects in the solar system, including planets, moons, and asteroids. It is also used to study the dynamics of planetary systems and to search for new planets and other objects in the universe. Satellite-based observations. Satellite-based observations are a powerful tool for accurately tracking the positions and movements of celestial objects. Satellites can be equipped with specialized instruments, such as cameras and telescopes, to observe the universe in different wavelengths of light. Satellite-based observations are used to study a wide range of celestial objects, including planets, stars, galaxies, and black holes. They are also used to study the cosmic microwave background radiation, which provides valuable insights into the early universe and the origins of the universe. Future directions. The accurate positioning and tracking of celestial objects is a crucial component of modern astronomy. In the coming years, advances in technology and observational techniques will continue to deepen our understanding of the positions and movements of objects in space. In addition, new missions and future observatories, such as the James Webb Space Telescope and the European Space Agency's Gaia mission, will provide unprecedented views of the universe and allow for more detailed observations and measurements of celestial objects. Radio astronomy. Radio astronomy is the study of celestial objects using radio waves. Radio telescopes can detect and measure radio waves emitted by celestial objects, which can provide valuable information about their position, velocity, and other characteristics. Radio astronomy is used to study a wide range of celestial objects, including pulsars, quasars, and other sources of radio emission. It is also used to study the structure and dynamics of the Milky Way galaxy and to search for extraterrestrial intelligence. Laser ranging. Laser ranging is a technique used to precisely measure the distance between the Earth and other celestial objects. This is typically done using laser beams that are directed at reflectors on the surface of the Moon or on artificial satellites in orbit around the Earth. Laser ranging is used to study the dynamics of the Earth-Moon system, including the motion of the Moon and the tides. It is also used to study the structure and dynamics of the solar system, including the positions and motions of planets and asteroids. Gravitational lensing. Gravitational lensing is a phenomenon in which the gravitational field of a massive object, such as a galaxy or a black hole, bends the path of light from a more distant object. This can cause the more distant object to appear distorted or magnified. Gravitational lensing is used to study the distribution of dark matter in the universe, as well as the structure and dynamics of galaxies and galaxy clusters. It is also used to search for exoplanets and to study the properties of black holes. Future directions. The precise positioning and tracking of celestial objects is a rapidly evolving field, with new discoveries and innovations constantly emerging. In the coming years, advances in technology and observational techniques will continue to deepen our understanding of the positions and movements of objects in space. In addition, new missions and future observatories, such as the Large Synoptic Survey Telescope and the Square Kilometre Array, will provide unprecedented views of the universe and allow for more detailed observations and measurements of celestial objects. Very Long Baseline Interferometry (VLB). Very Long Baseline Interferometry (VLB) is a technique used to combine data from multiple radio telescopes located at different locations on the Earth to create a virtual telescope with a resolution equivalent to a single dish with a diameter equal to the distance between the telescopes. VLB is used to study a wide range of celestial objects, including quasars, pulsars, and black holes. It is also used to study the structure and dynamics of the Milky Way galaxy and to search for extraterrestrial intelligence. Astrophotography. Astrophotography is the technique of capturing images of celestial objects using telescopes and specialized cameras. These images can provide valuable information about the position, size, and other characteristics of celestial objects. Astrophotography is used to study a wide range of celestial objects, including galaxies, nebulae, and star clusters. It is also used to study the structure and dynamics of the Milky Way galaxy and to search for exoplanets. Transit photometry. Transit photometry is a technique used to detect exoplanets by measuring the slight decrease in the brightness of a star as a planet passes in front of it. This can provide valuable information about the size, orbit, and other characteristics of exoplanets. Transit photometry is used to study a wide range of exoplanets, including super-Earths, hot Jupiters, and potentially habitable Earth-like planets. It is also used to search for signs of life on exoplanets by studying their atmospheres. Future directions. The influence of other celestial bodies on the orbits of the planets. The orbits of planets in our solar system are determined by the gravitational forces between the planets and the Sun. However, the presence of other celestial bodies, such as asteroids, comets, and even other planets, can have a significant impact on the orbits of planets. Asteroids and comets. Asteroids and comets are small celestial bodies that orbit the Sun. When these objects pass near a planet, they can perturb its orbit and cause it to deviate from its predicted path. For example, the asteroid belt located between Mars and Jupiter contains many small asteroids that can occasionally collide with planets in the inner solar system. These collisions can cause significant changes in the orbit of a planet, leading to changes in its position and velocity. Comets also have a significant impact on the orbits of planets. When a comet passes close to a planet, its gravitational pull can cause the planet's orbit to change. In addition, comets can also collide with planets, causing significant changes in their orbits and potentially leading to mass extinctions. Other planets. The gravitational pull of other planets in the solar system can also have a significant impact on the orbits of planets. This effect is known as planetary perturbation and is particularly important for planets that are located far from the Sun. For example, the planet Neptune was discovered in 1846 after astronomers noticed that the orbit of Uranus was deviating from its predicted path. It was later determined that the gravitational pull of Neptune was causing Uranus to deviate from its predicted orbit. Similarly, the discovery of Pluto in 1930 was also due to the observed perturbations in the orbit of Neptune. The discovery of Pluto led to the recognition of the Kuiper Belt, a region of the solar system containing many small icy objects that can perturb the orbits of planets. Future directions. The study of the impact of celestial bodies on the orbits of planets is a rapidly evolving field, with new discoveries and innovations constantly emerging. In the coming years, advances in technology and observational techniques will continue to deepen our understanding of the dynamics of the solar system. In addition, new missions and future observatories, such as the Europa Clipper and the James Webb Space Telescope, will provide unprecedented views of the solar system and allow for more detailed observations and measurements of the orbits of planets. Tidal forces. Tidal forces are the gravitational forces that occur between two objects when they are close together. These forces can cause the objects to become stretched out or deformed, and can also cause changes in their orbits. When a planet is close to a large moon, the tidal forces between the two objects can cause the planet's orbit to become more elliptical. With the distance between the planet and the moon varying over time. Over time, this can cause the planet's orbit to become more stable or more chaotic, depending on the specific circumstances. In addition, tidal forces can also cause the rotation of a planet to become synchronized with the orbit of its moon, as is the case with the Moon and Earth. This can lead to a phenomenon known as tidal locking, in which one side of the planet always faces the Moon. Stellar encounters. Stellar encounters occur when two stars pass close to each other in space. These encounters can have a significant impact on the orbits of planets in the vicinity. When a star passes close to our solar system, it can perturb the orbits of the planets and cause them to become more elliptical. This can lead to changes in the position and velocity of the planets, and in some cases, can even cause planets to be ejected from the solar system entirely. In addition, stellar encounters can also lead to the capture of rogue planets, which are planets that do not orbit a star. When a rogue planet passes close to a star, the gravitational pull of the star can cause the planet to be captured and begin orbiting the star. Future directions. The study of the impact of celestial bodies on the orbits of planets is a rapidly evolving field, with new discoveries and innovations constantly emerging. In the coming years, advances in technology and observational techniques will continue to deepen our understanding of the dynamics of the solar system. In addition, new missions and future observatories, such as the Nancy Grace Roman Space Telescope and the European Extremely Large Telescope, will provide unprecedented views of the solar system and allow for more detailed observations and measurements of the orbits of planets. Resonances. Resonances occur when the orbital periods of two celestial bodies are related by a simple fraction, such as 2 to 1 or 3 to 2. When this happens, the gravitational influence of one body on the other can become amplified, leading to changes in the orbits of both bodies. For example, the orbital period of Neptune is about 165 years, while the orbital period of Pluto is about 248 years. This means that the two objects have a 3 to 2 resonance, with Pluto completing 2 orbits around the Sun for every 3 orbits completed by Neptune. This resonance can lead to significant changes in the orbits of both objects over time. Resonances can also occur between planets and their moons. For example, the moons of Jupiter are in resonant orbits, with the orbital periods of some moons related by simple fractions. These resonances can lead to complex gravitational interactions between the moons and can also impact the orbits of Jupiter itself. Galactic tides. Galactic tides are the gravitational forces that occur between a galaxy and its constituent stars, gas and dust. These forces can cause the orbits of objects within the galaxy to become more elliptical or chaotic over time. In addition, galactic tides can also cause the orbits of objects outside the galaxy to be perturbed. For example, when a star or planet passes close to the edge of a galaxy, the galactic tides can cause the object's orbit to become more elliptical or even be ejected from the galaxy entirely. For example, when a star or planet passes close to the edge of a galaxy, the galactic tides can cause the object's orbit to become more elliptical or even be ejected from the galaxy entirely. Future directions. Sources of artificial radio waves. Artificial radio sources are electromagnetic signals transmitted from devices created and operated by humans. These signals have many uses, from communication to navigation, and have become a ubiquitous part of modern life. Radio communication. One of the primary uses of artificial radio sources is communication. Radio waves can be used to transmit information over long distances, and are used in a wide range of applications, from cell phones to radios to satellite communications. Radio communication is used in many fields, including aviation, maritime, public safety, and military operations. Radio communication can be used to transmit voice, data, and images, and is an essential tool for many professions. Navigation. Artificial radio sources are also used for navigation. GPS, or Global Positioning System, is a network of satellites that transmit radio signals to ground-based receivers, allowing them to determine their precise location on Earth. GPS is used in a wide range of applications, from navigation in cars and airplanes to tracking the movement of wildlife. GPS has also become an essential tool for precision agriculture, allowing farmers to optimize crop yields and reduce waste. Scientific research. Artificial radio sources are also used in scientific research. Radio telescopes are used to study the universe, detecting and analyzing the radio waves emitted by celestial objects. Radio telescopes can be used to study a wide range of objects, from stars and galaxies to black holes and quasars. Radio astronomy has led to many important discoveries in astrophysics, including the discovery of pulsars and the cosmic microwave background radiation. Future directions. The use of artificial radio sources is a rapidly evolving field, with new technologies and applications constantly emerging. In the coming years, advances in technology and research will continue to push the boundaries of what is possible with artificial radio sources. In addition, new missions and future observatories, such as the Square Kilometre Array, and the Next Generation Very Large Array, will provide unprecedented views of the universe and allow for more detailed observations and measurements of celestial objects. Weather forecasting. Artificial radio sources are used in weather forecasting to gather data on atmospheric conditions. Radiosondes are devices that are carried by balloons and transmit data on temperature, humidity, pressure, and wind speed as they ascend through the atmosphere. In addition, radar systems use radio waves to detect precipitation and measure its intensity and movement. This information is used to generate weather forecasts and issue warnings for severe weather events. Military applications. Artificial radio sources have many military applications, including communication, navigation, and surveillance. Radio communication is used by military personnel to coordinate operations and share information. In addition, artificial radio sources are used for navigation in military operations. GPS is an essential tool for navigation in the field, allowing military personnel to accurately determine their location and navigate to their destination. Surveillance is another application of artificial radio sources in military operations. Radar systems can be used to detect and track aircraft and other objects, providing critical information for air defense and other military operations. Wireless power transmission. Artificial radio sources can also be used for wireless power transmission. This technology uses radio waves to transmit electrical power from a power source to a device without the need for wires. Wireless power transmission has many potential applications, including charging electric vehicles, powering wireless sensors, and providing power to remote locations. However, the technology is still in the early stages of development and faces many technical and regulatory challenges. Future directions. The use of artificial radio sources is a rapidly evolving field, with new technologies and applications constantly emerging. In the coming years, advances in technology and research will continue to push the boundaries of what is possible with artificial radio sources. In addition, new missions and future observatories, such as the Next Generation Very Large Array and the SKA Observatory, will provide unprecedented views of the universe and allow for more detailed observations and measurements of celestial objects. Radio frequency identification. Radio frequency identification (RFID) is a technology that uses artificial radio sources to identify and track objects. RFID tags are small electronic devices that are attached to objects and transmit a unique identifier when they are scanned by a reader. RFID technology has many applications, including inventory management, asset tracking, and contactless payment systems. RFID tags can be used to track the movement of goods in a warehouse or to monitor the location of equipment in a hospital. Radiotherapy. Artificial radio sources are also used in medical applications, particularly in radiotherapy. Radiotherapy uses high-energy radiation to destroy cancer cells and shrink tumors. Radiotherapy can be delivered using external beam radiation therapy, which uses a machine called a linear accelerator to deliver radiation to the affected area. In addition, radiotherapy uses artificial sources of radiation that are placed inside the body to treat cancer. Security screening. Artificial radio sources are also used in security screening, particularly in airport security. X-ray machines and millimeter wave scanners use artificial radio sources to generate images of objects and people, allowing security personnel to detect weapons, explosives, and other prohibited items. In addition, metal detectors use artificial radio sources to detect metallic objects on a person's body. These technologies have become essential tools for ensuring the safety of air travel and other forms of transportation. Strange astronomical phenomena. Astronomy is a fascinating field that has captured the imaginations of people for centuries. While many astronomical phenomena are well understood, there are still some that remain mysterious and unexplained. In this article, we will explore some of the most bizarre and unexplained astronomical phenomena. Fast radio bursts. Fast radio bursts, FRBs, are intense bursts of radio waves that last only a few milliseconds. They were first detected in 2007 and have been observed by telescopes around the world. The origin of FRBs is still unknown, but they are believed to be extragalactic in origin. Some theories suggest that they may be caused by the collision of two neutron stars or the collapse of a supermassive star. Dark energy and dark matter. Dark energy and dark matter are two mysterious substances that make up the majority of the universe. Dark matter is a form of matter that does not emit, absorb, or reflect light, and is therefore invisible to telescopes. Dark energy is a force that is believed to be causing the expansion of the universe to accelerate. The nature of dark matter and dark energy is still unknown, but they are believed to play a critical role in the evolution and structure of the universe. Scientists are continuing to study these mysterious substances in the hopes of gaining a better understanding of their properties and origins. Black holes. Black holes are some of the most mysterious and fascinating objects in the universe. They are regions of space where gravity is so strong that nothing, not even light, can escape. The behavior of matter and energy around black holes is still not fully understood. However, recent studies have provided new insights into the behavior of black holes, including the discovery of gravitational waves, which are ripples in the fabric of spacetime caused by the collision of two black holes. Gamma-ray bursts. Gamma-ray bursts, GRBS, are intense bursts of gamma rays that last only a few seconds. They are believed to be some of the most energetic events in the universe, releasing more energy in a few seconds than the Sun will release in its entire lifetime. The origin of GRBS is still unknown, but they are believed to be caused by the collapse of massive stars of the collision of two neutron stars. GRBS are also of interest to astronomers because they may provide clues about the early universe and the formation of stars and galaxies. Pulsars. Pulsars are rapidly rotating neutron stars that emit beams of radiation from their magnetic poles. As the star rotates, the beam of radiation sweeps across the sky, creating a pulsing effect that can be detected by telescopes on Earth. The behavior of pulsars is still not fully understood, but they are believed to be some of the most precise clocks in the universe. Pulsars are also of interest to astronomers because they can be used to study the structure and evolution of galaxies. Quasars. Quasars are extremely bright, distant objects that emit massive amounts of energy. They are believed to be powered by supermassive black holes at the centers of galaxies. The behavior of quasars is still not fully understood, but they are believed to be some of the most energetic objects in the universe. Quasars are also of interest to astronomers because they provide clues about the early universe and the formation of galaxies. Galactic cannibalism. Galactic cannibalism is the process by which one galaxy absorbs another. This phenomenon is believed to be common in the universe, as galaxies are constantly interacting and merging with each other. The behavior of galactic cannibalism is still not fully understood, but it is believed to play a critical role in the evolution and structure of galaxies. By studying galactic cannibalism, astronomers can gain insights into the formation and evolution of the universe. The Great Attractor. The Great Attractor is a mysterious region of space that is pulling galaxies towards it at an incredible speed. The nature of the Great Attractor is still not fully understood, but it is believed to be a massive concentration of dark matter in galaxies. The behavior of the Great Attractor is of interest to astronomers because it provides clues about the structure and evolution of the universe. By studying the Great Attractor, astronomers can gain insights into the distribution of matter in the universe and the forces that shape it. Supernovae. Supernovae are incredibly powerful explosions that occur when a star runs out of fuel and collapses in on itself. These explosions release massive amounts of energy and can briefly outshine entire galaxies. The behavior of supernovae is still not fully understood, but they are believed to play a critical role in the evolution of the universe. By studying supernovae, astronomers can gain insights into the formation of stars and galaxies, the production of heavy elements, and the expansion of the universe. Cosmic rays. Cosmic rays are high-energy particles that originate from outside the solar system. They are believed to be produced by supernovae, black holes, and other energetic events in the universe. The behavior of cosmic rays is still not fully understood, but they are of interest to astronomers. Because they provide insights into the structure of the universe and the nature of high-energy phenomena. By studying cosmic rays, astronomers can gain insights into the origins of these particles and the forces that shape the universe. Exoplanets. Exoplanets are planets that orbit stars other than the Sun. They are of interest to astronomers because they provide insights into the formation and evolution of planets and the prevalence of life in the universe. Various astronomical light sources. Astronomy is the study of celestial objects and phenomena in the universe, and one of the most important aspects of this field is the study of different types of astronomical light sources. In this article, we will explore the various types of astronomical light sources that are studied by astronomers. Stars. Stars are perhaps the most well-known astronomical light sources. They are massive, luminous objects that produce their own light through nuclear fusion reactions in their cores. The light emitted by stars provides astronomers with a wealth of information, including their temperature, composition, and distance from Earth. There are many different types of stars, including main sequence stars, giant stars, and supergiants. Each type of star has its own unique characteristics and behaviors, and studying them provides astronomers with insights into the formation and evolution of galaxies. Galaxies. Galaxies are massive collections of stars, gas, and dust that are held together by gravity. They come in a variety of shapes and sizes, including spiral, elliptical, and irregular. The light emitted by galaxies provides astronomers with insights into their structure, composition, and evolution. The study of galaxies is important for understanding the formation and evolution of the universe. By studying the way galaxies form and interact with each other, astronomers can gain insights into the forces that shape the universe. Nebulae. Nebulae are clouds of gas and dust that are illuminated by nearby stars. They come in a variety of shapes and sizes, including emission nebulae, reflection nebulae, and planetary nebulae. The light emitted or reflected by nebulae provides astronomers with insights into their composition and the processes that shape them. The study of nebulae is important for understanding the formation of stars and planetary systems. By studying the way nebulae form and interact with nearby stars, astronomers can gain insights into the forces that drive the formation of stars and planets. Quasars. Quasars are extremely bright, distant objects that emit massive amounts of energy. They are believed to be powered by supermassive black holes at the centers of galaxies. The light emitted by quasars provides astronomers with insights into the nature of black holes and the evolution of galaxies. The study of quasars is important for understanding the structure and evolution of the universe. By studying the way quasars form and interact with galaxies, astronomers can gain insights into the forces that shape the universe. Gamma ray bursts. Gamma ray bursts, GRBS, are intense bursts of gamma rays that last only a few seconds. They are believed to be some of the most energetic events in the universe, releasing more energy in a few seconds than the Sun will release in its entire lifetime. The light emitted by GRBS provides astronomers with insights into the formation and evolution of stars and galaxies. The study of GRBS is important for understanding the forces that drive the formation of stars and the role that they play in the evolution of the universe. Cosmic microwave background radiation. Cosmic microwave background radiation, CMB, is the afterglow of the Big Bang. It is a faint glow of light that fills the universe in all directions. The light emitted by the CMB provides astronomers with insights into the early universe and the conditions that existed shortly after the Big Bang. The study of CMB is important for understanding the origins and evolution of the universe. By studying the fluctuations in the CMB, astronomers can gain insights into the structure of the early universe and the forces that shaped it. Supernovae. Supernovae are incredibly powerful explosions that occur when a star runs out of fuel and collapses in on itself. These explosions release massive amounts of energy and can briefly outshine entire galaxies. The light emitted by supernovae provides astronomers with insights into the formation and evolution of stars and galaxies. The study of supernovae is important for understanding the forces that drive the formation of stars and the role that they play in the evolution of the universe. Black holes. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. The light emitted by black holes is difficult to study directly, but astronomers can observe the effects of black holes on nearby objects, such as stars and gas. The study of black holes is important for understanding the behavior of matter and energy in extreme environments. By studying the effects of black holes on nearby objects, astronomers can gain insights into the nature of gravity and the behavior of matter in the universe. Interstellar gas and dust. Interstellar gas and dust are the raw materials from which stars and planets are formed. They are composed of elements such as hydrogen, helium, and carbon, as well as heavier elements that are produced in the cores of stars. The light emitted or reflected by interstellar gas and dust provides astronomers with insights into the conditions necessary for the formation and evolution of stars and planets. The study of interstellar gas and dust is important for understanding the processes that drive the formation of stars and planets in the universe. White dwarfs. White dwarfs are compact objects that are formed when low-mass stars run out of fuel and collapse in on themselves. They are extremely dense, with a mass comparable to that of the Sun and a size comparable to that of the Earth. The light emitted by white dwarfs provides astronomers with insights into the structure and evolution of stars. The study of white dwarfs is important for understanding the behavior of matter in extreme environments and the role that low-mass stars play in the evolution of the universe. Active galactic nuclei. Active galactic nuclei, AGN, are extremely bright regions at the centers of galaxies that emit massive amounts of energy. Historical astronomical events. Throughout history, there have been a number of astronomical events that have captivated and intrigued people around the world. From comets and eclipses to supernovae and planetary alignments, these events have been documented in various forms of literature and art, and have left a lasting impact on human culture. In this article, we will explore some of the most significant and memorable astronomical events in history. Comets. Comets have been observed and documented throughout history. They are icy bodies that orbit the Sun and develop a glowing tail when they approach the inner solar system. Comets were often seen as omens or portents of significant events, such as wars or natural disasters. The appearance of Halley's Comet in 1066, for example, was seen as a sign of the impending Norman invasion of England. Eclipses. Eclipses occur when the Moon passes between the Sun and the Earth, or when the Earth passes between the Sun and the Moon. They have been observed and documented by various cultures throughout history. Eclipses were often seen as supernatural events and were interpreted as signs of impending doom or the wrath of the gods. In 585 BC, for example, a total solar eclipse occurred during a battle between the Lydians and the Medes, and the event was said to have caused the two sides to make peace. Supernovae. Supernovae are incredibly powerful explosions that occur when a star runs out of fuel and collapses in on itself. They release massive amounts of energy and can briefly outshine entire galaxies. Supernovae have been observed and documented by astronomers throughout history, and they were often seen as omens or portents of significant events. The supernova of 1006 AD, for example, was recorded by many cultures around the world and was said to have been visible during the day for several weeks. Planetary alignments. Planetary alignments occur when two or more planets appear close together in the sky. They have been observed and documented throughout history, and were often seen as significant events. In 2 BC, for example, a planetary alignment occurred that was said to have been a sign of the birth of Jesus Christ. Transits. Transits occur when a planet passes directly in front of the Sun from the perspective of Earth. They are relatively rare events that have been observed and documented throughout history. The transit of Venus in 1761 and 1769, for example, was a significant event for astronomers as it allowed them to make accurate measurements of the distance between the Earth and the Sun. Meteor showers. Meteor showers occur when the Earth passes through a trail of debris left behind by a comet or asteroid. They have been observed and documented throughout history, and were often seen as supernatural events. The Leonid meteor shower of 1833, for example, was said to have caused a panic as people believed that the sky was falling. Lunar landings. Lunar landings are arguably the most significant astronomical events in human history. They occurred during the Apollo missions of the 1960s and 1970s, when astronauts landed on the Moon and conducted scientific experiments. The first lunar landing, by the Apollo 11 mission in 1969, was watched by millions of people around the world and is seen as a defining moment in human history. Trans-Neptunian objects. Trans-Neptunian objects, TNOs, are objects in the outer solar system that orbit beyond Neptune. They include dwarf planets such as Pluto and Eris, as well as other icy bodies. The discovery of Pluto in 1930 was a significant event in the history of astronomy, and the reclassification of Pluto as a dwarf planet in 2006 sparked controversy and debate among astronomers and the general public. Halley's Comet. Halley's Comet is one of the most famous comets in history, and it has been observed by people for centuries. The comet is named after astronomer Edmund Halley, who predicted its return in 1759. The comet has been associated with numerous significant events throughout history, including the Battle of Hastings in 1066 and the Great Fire of London in 1666. The Milky Way Galaxy. The Milky Way Galaxy has been observed and studied by astronomers for thousands of years. In ancient times, the Milky Way was seen as a band of light in the night sky, and it was often associated with various mythological beliefs. In the 17th century, Galileo Galilei used a telescope to observe the Milky Way and discovered that it was made up of countless stars. The Hubble Deep Field. The Hubble Deep Field is a series of images taken by the Hubble Space Telescope in 1995. The images show a tiny patch of sky that contains thousands of galaxies, some of which are billions of light-years away. The images provided astronomers with a new understanding of the size and scale of the universe, and they continue to be studied and analyzed by astronomers today. The Great Red Spot on Jupiter. The Great Red Spot on Jupiter is a giant storm that has been observed by astronomers for centuries. The storm is larger than the size of Earth and has been raging for at least 400 years. The storm is believed to be caused by high-speed winds in Jupiter's atmosphere, and it continues to be studied by astronomers today. The transit of Mercury. The transit of Mercury is a rare event that occurs when the planet Mercury passes directly between the Earth and the Sun. The event is visible from Earth and takes place only a few times per century. The transit of Mercury was first observed in 1631 by French astronomer Pierre Gassendi, and the event has been studied by astronomers ever since.